Good morning students. Hope all of you are well and safe. Okay. Our term 1 exam is knocking at the door. So from your term 1 syllabus, now we will focus on the practicals. Okay. In first practical that we are doing to perform, that is your to determine the strength of dilute HCl using standard M/20 sodium carbonate solution. Okay students, so what is the aim of our experiment? We will try to find the strength, okay, the strength of HCl using sodium carbonate solution. Okay students, sodium carbonate is the standard solution. Standard solution means the solution whose strength is known to us. Okay, so using the standard sodium carbonate solution, we will try to find the strength of HCl solution. Okay, this we will do with the help of titration. That is why in procedure it is already mentioned as titration. What is titration? In titration, we will find the strength of an unknown solution with the help of a standard solution. For example, if we focus on the M, in this case our standard solution is sodium carbonate. So this is the known solution, and with the help of this solution we will find the strength of HCl solution, which is our unknown solution. Okay, so the aim of titration is clear. We will try to find the strength of unknown solution. In this case it is our dilute HCl with the help of standard solution whose strength is already mentioned as M/20. What is M? This capital M stands for your molarity, and this we will perform with the help of titration. So students, we have already discussed that this experiment we will conduct with the help of titration. Okay, now for every experiment this theory part is very important. That is, what is the mechanism going on behind this experiment. So what we can find that sodium carbonate reacts with HCl, hydrochloric acid, and this reaction will be according to this format, which is already written in the board. Sodium carbonate reacts with hydrochloric acid, it will form sodium chloride, carbon dioxide and water. The upward arrow is due to the liberation of gas, because we all know that carbon dioxide is a gas. This reaction students is very common to us. We are very much familiar with this reaction, because this we have done in class 10, that when acids react with carbonates and bicarbonates, they will give salt, water and carbon dioxide. In this case, sodium carbonate is the metallic carbonate. It reacts with HCl to form the salt called sodium chloride, common salt, table salt, along with evolution of carbon dioxide gas, along with formation of water. So this is the theoretical part, this is the theory which is involved behind this experiment. Okay, so students, now we will proceed to the chemicals part. What are the chemicals that we need during this titration? We need sodium carbonate, we need dilute hydrochloric acid, as well as we need methyl orange. Students, as the name suggests, methyl orange, that means this indicator will be orange in color. It is already known from its name. Now, why this indicator is required? Because this will help to determine the end point. It varies from titration to titration. Okay. Last but not the least, that is our apparatus required. We need various types of apparatus during titration. With the progress of time, we will be acquainted with these apparatus, but for this titration we need burette, we need conical flask, we need funnel, we need beaker, we need measuring cylinder, and also we need our pipette. So this is, students, this is the theoretical overview of this titration. In the latter words, we will carry out our activity part, which is the most fundamental part in this case. Okay. So, okay students, we have already discussed the theoretical part. Now we are coming to the main part, that is our experimental part. Okay. In experimental part, we have to be very much careful because we will be handling with this glass apparatus. Okay. So first what we will do, we can see that this is the burette which is clamped with a stand. So that we will call it as burette with burette stand. Okay. First step will be our rinsing the burette with our dilute hydrochloric acid. Okay students. So this is our dilute hydrochloric acid. This is our dilute hydrochloric acid. We will put a little amount of dilute hydrochloric acid in the burette. So we have put a little amount of dilute hydrochloric acid, then we will rotate this burette gently, okay, so that HCl gets attached with the walls of the burette. Okay. So it is almost done. Now we have to discard this dilute HCl. There is the discarded pot, we should discard it in this beaker. So this rinsing part is over. We will consider this experiment, we will perform in a sequence of steps. So first one is the rinsing part, which is already done. Now we will fill up this burette with again dilute hydrochloric acid. The mark will be from 0 to 50. We will fill up to 0. Our mark will be 0, students. So we are filling with help of dilute hydrochloric acid. We have to take a close watch. So students, we can see that we have filled the burette up to this 0 level mark. Okay, this is the 0 level mark and the total volume is from 0 to 50. Okay. Clear? So the second step is done, that we have taken dilute hydrochloric acid in our burette. Students, we have to determine the strength of this dilute hydrochloric acid, and this will be determined with the help of sodium carbonate. We will pipette out this sodium carbonate solution 20 ml in a conical flask. Okay. Students, this pipetting out will be carried out with the help of a pipette. We can already find that this is a 20 ml pipette. It is already written in the walls of the pipette. This is the 20 ml pipette. So we will now try to pipette out this sodium carbonate solution. Okay, students. We are pipetting out sodium carbonate. So students, now we are pipetting out 20 ml. Look students, there is a mark. We have to maintain the solution up to this mark, but for right now I have taken a little higher amount. Now we have to adjust it. So I am now adjusting the volume up to this mark. This mark will give you the exact 20 ml mark. Okay. So students, I am now just adjusting. So now students, you can find that the volume is adjusted to 20 ml, already written in the bulb 20, and there is a mark it is touching this layer, so that will be our 20 ml mark. Now this sodium carbonate solution, we will transfer it into this conical flask. Okay, we are transferring. While transferring, students, you have to be very careful that not a single drop of this sodium carbonate should remain in this pipette. So we are taking a close look that whether all the solutions has been transferred or not. Okay. So we have already filled the burette with dilute hydrochloric acid, and we are pipetting out 20 ml of this sodium carbonate solution and transferring it into a conical flask. Students, now we have ensured that not a single drop is remaining in this pipette. So now we are keeping this pipette aside. So that is our third step. And students, what I have already mentioned that during any titration we need an indicator, and as the name suggests, this is your methyl orange. So we can easily find that this is orange in color. So it is appropriate according to its name. So methyl orange is the indicator which we will be using in this case. Okay, students. Now the question is how much we will add. We need a very small amount. So that is why we will take only 4 to 5 drops of this indicator, students. So look, we are using this 4 to 5 drops. Okay. So what is the color change? This is your orange. We can see the difference, students. We can see the difference. The indicator is in my right hand, which is orange in color, and after putting the indicator into the solution, look, it has become yellow in color. So that is the initial difference what we are looking for. We can easily make this difference. So I am keeping the indicator aside. Now this is our final solution which contains sodium carbonate along with this methyl orange. Now we are titrating this solution. Again, students, during titration there are certain techniques. Okay. First, what is the technique? We have to use both of our hands during titration. Our right hand, my right hand will be holding this conical flask, and my left hand will be at the knob. My left hand will be at the knob of this burette. My left hand will be controlling the knob and my right hand will be shaking the solution. These two processes will be simultaneous in nature, and we have to watch how the color is changing. Okay, students. So my left hand, I am putting it at the knob, and my right hand is already holding the solution. Now let us start the titration procedure. So students, I have adjusted to a single drop to ensure that only one drop will fall into the solution, and then we will make this titration. Okay, students. So now see, one drop is coming into the solution and we are constantly shaking it. We are constantly shaking. My left hand is controlling the knob and my right hand is constantly shaking the solution. We have to see the color change, how the color changes from yellow. This process should be continuous in nature. Students, you have to be patient during this time. Don't be in a rush, otherwise you will get error in result. At the same time, students, we have to take a watch that what is the reading. Still now we are having yellow color, so that is why we are adding drop by drop. Still yellow, the color is becoming fade. So students, look, the color is changing. So finally students, we have give this light or faint pink color. So that will be the color at the end point. So initially students, our color was yellow when we have added methyl orange, and after titrating this with dilute hydrochloric acid, this should be the final color. Okay. And then students, we have to take a watch. How we will do this? We will take out this burette from the stand and we will take the reading parallel to our eye, so that there is no parallax error, and we have find that this reading is almost 20.7. It is already students 20.7. This reading is very essential for our calculation, and this we will repeat it for 3 times to get accurate result. The procedure will be same in every case. Okay. So students, we have observed the change in color during the titration. So that is why it is already mentioned as end point. End point is the point of neutralization, where we will find this color change. So initially the color of the solution was yellow after putting the indicator, but when we have titrated with dilute hydrochloric acid, this color has changed from faint pink. So if anyone asks you that what is the color change during this titration, what we will say that? We will say that it will be from yellow to faint pink. So this is the end point of this titration. Let us come to the observation table. Here we have to do certain calculations to get the result. So already students, it is written as serial number. Serial number means how many titrations we will carry out. We have already mentioned that for getting accurate result, we will carry out 3 titrations. So students, it is written as volume of sodium carbonate in ml. So what volume students we have pipetted out? We have pipetted out 20 ml. So here I will write it as 20 ml. Now initial, what is the range of this burette marking? It starts from 0 and ends in 50. So initially, whenever we will carry out our titration, our initial value students will always be 0. So it will be 0. And final means the reading at which this pink color has arrived. So we have found that this pink color has arrived at the reading of 20.7, which we have found through our burette reading. So final will be our 20.7. So students, difference, what is the difference? Difference always suggests the difference between final and the initial, difference between final reading and initial reading. So final it was 20.7, initially it was 0, so therefore the difference will be 20.7 ml. So students, this is the reading in our first case. So similarly, we will carry out the second and the third titration. The values will be more or less same or almost same. So every time we will pipette out 20 ml of sodium carbonate. In every case, initial will be suppose our 0 and this will be suppose 20.7. So finally difference will be 20.7. So that is the mean. So when we take the mean, it will be 20.7. Now students, we will come to the calculation part, which we actually need, the strength of dilute hydrochloric acid. So the formula will be V1S1 by N1 equals to V2S2 by N2. Obviously these letters represent certain indications or meanings. What are these? What is V1? V1 is volume of dilute hydrochloric acid. The volume we have measured through the burette reading, and that will be your 20.7. This is the volume of dilute HCl. Strength S1 is the strength of HCl. Students, this we have to determine. The strength of HCl is unknown. So S1 is the unknown quantity. N1 means coefficient of HCl. In the equation, students, we have found that we need 2 moles of HCl. So that is why the coefficient N1 is given as 2. What is N2? N2 is the coefficient of sodium carbonate. In this case, whatever we have find in the reaction, that we need only 1 moles of sodium carbonate. So that is why our N2 will be 1. N1 is known, students, in the equation 2. N2 is known, students, in the equation 1. V1 volume of HCl is known in the equation. V2, that is the volume of sodium carbonate. That volume we have pipetted out, that is our 20 ml. So students, V2 is also known, V1 is known, V2 is known, N1 is known, N2 is known. S2, students, strength of sodium carbonate. In the M, students, we have already mentioned that the strength will be of the order M by 20. So this S2 is also known. So students, the only unknown quantity will be S1. If all these quantities are known, we can easily find the strength, and that will be in terms of molarity. But our aim is to find the strength, and that will be in terms of grams per liter. So to get the answer in grams per liter, this molarity, what we are obtaining in the form of S1, that must be multiplied with the molar mass or the molecular weight of HCl, and then we will get the final result. So in result, what we can say, that the strength of dilute hydrochloric acid will be the molarity that we are obtaining from the calculation S1, followed by the molecular weight of HCl, which will be 36.5, and that will be in the final terms of gram per liter. Okay, that's all.